is a constant rate, and then the distance that the object or whatever travels, right, is the constant rate multiplied by the time duration that it's traveling for. So if I say that I walk at a pace of 5 miles per hour for 3 hours, right? Then how much distance am I traveling? If my rate is constant, if it's not stopping or anything like that. You guys can share it by unmuting or typing in the chat. So, if I walk for a constant speed of 5 miles per hour, and I walk for the ridiculously long amount of 3 hours, right? What's the total distance that I'm traveling in these 3 hours? Can anyone feel free to jump in? It's fine. You guys can either type it on the chat or. So we want to use the formula, which is a distance equals rate times time. So rate here is a constant 5 miles per hour, and then our time that we are traveling the rate for is 3 hours. So if we use the formula, we can get that we travel for a total of 15 miles. And obviously, a really important note to make here is that the rate has to be constant. You can't say that I'm walking for a distance of 5 miles per hour for an hour, and then I stop for 2 hours, or and I yeah sure, and I stop for 2 hours. Then what's the distance that I'm traveling? You have to account for the stopping as well in that distance, right? Like you can't just say that you travel for 5 miles per hour for 3 hours, right? Because you're stopping there for 2 hours. Does that make sense? So like you can't like also if you consider something like I walk for 5 miles per hour for 30 minutes, right? So 5 miles per hour, 30 minutes, right? And then for the other 30 minutes, I just stop there and I continue this for 3 hours. So what's the total distance that I traveled? I can't just say that I walked 5 miles per hour for the whole 3 hours, right? Because I didn't. I didn't go at a constant rate of 5 miles per hour for the whole 3 hours. I went for 5 miles per hour for half an hour, and then I stopped for half an hour, and then I moved on. So my actual distance would be half of this, right? Because if I'm traveling 5 miles per hour for 3 hours and I get 15 miles per hour or 15 miles, then if I travel at 5 miles per hour for 30 minutes, this is traveling 5 miles per hour for 3 hours, right? And so if I travel for 5 miles per hour, 30 minutes, and then I travel for 3 hours like this, right? So the 5 miles per hour and then 0 miles per hour because I just stopped there for 30 minutes. Then in 3 hours, I travel half this distance because I'm stopping for half the time. Does that make sense? All right. So so we can go over this problem, which says that Beth takes an hour to walk to school and 15 minutes to bike back home. Her home is 5 miles her home is 5 miles. Her school is 5 miles from her home. This is a typo. Her school is 5 miles from her home, right? So what is her average speed in miles per hour of her commute to school and back? So what's her average speed is what we're trying to say. Does anyone have any ideas on how we could approach this? So again, right? Um, if you guys have any ideas, you can just share in the chat, or you guys can just speak out. That's fine. If you don't, that's perfectly fine as well. Okay. Um, Anyone have any ideas? Last call before I go over the solution. Uh, Hygiene. That's close. Yeah, I'd say that's close, but not quite. So I'll just go over the solution. So first of all, can anyone tell me what the distance involved in this problem is? Because okay, fine. First, can we see that this is a distance equals rate times time kind of problem? Right. Okay. So we've defined the average speed, right, in miles per hour of her distance or of her travel journey, right? So if this is a distance equals rate times time kind of problem, then what's the distance that's involved in this problem? So what's the distance that Beth is traveling? I guess 10 miles. Yeah, Lee Kong. That's good. So um so we want to see that the question says of her commute to school and back, right? So so sorry, I just well. Okay, yeah. That's a good note. That's good for me to know. All right. Can you guys see the screen? Can you guys see this? Yeah, right now you can't, right? All right. Yeah. All right, how about now? Can you guys see the screen? All right. Sounds good. So, as we were saying, right? Oh my bad. So as we were saying, right? Um, her school is 5 miles from her home, and we want to talk about the commute to school and back, right? So our total distance is gonna be our total distance is gonna be 5 times 2, right? Because she travels 5 miles per hour to school and then back. Right. So our total distance is 10 miles. I think what people can forget is that they see that 5 miles and they think that that's the total distance. And so they just kind of, without thinking, just put down 5 miles because that's a distance kind of measures. But you always want to see what the problem's talking about. And the problem talks about like the commute to school and then back. So you go 5 miles and then you come back 5 miles. Does that make sense? It's 10 miles. Right. And now we want to find the total time, right? Because that's what we want to do to get the average rate, right? So total time. So what's our total time? And by the way, the problem says in miles per hour. So yeah, 1 hour 15 minutes. How can you write that just in terms of hours instead of instead of minutes? All right. Yeah, I got it. Um, so how can you um write the time just in terms of hours and not minutes? Because as you said, it's 1 hour 25 minutes, uh, but what's the time in terms of just hours? Like, by the way, a hint: this is a decimal, so it's a decimal number of hours. If that's a hint. So does anyone know? A Lee Kong, that Hubert, that's close. Um, yeah. Um, by the way, what's your name? Laura Nan, what's your name? Ryan. Yeah, yeah, Ryan, that's right. So 1.25 hours, right? Because, and for those of you that didn't get why this is the case, let's analyze the time, right? So it takes an hour, right? 1 hour. And then, so it takes 1 hour the for Beth to go to school, and then she bikes back home. So 15 minutes, right? 15 minutes is gonna be so 15 minutes in terms of hours is, so we can analyze this like that. So 15 minutes, right, is, so we know that there's 60 minutes in an hour, right? So how many hours does 15 minutes have? Because 60 minutes in an hour. So 15 minutes is how many hours? 0.25, right? A fourth of an hour, right? Because you can kind of think about the 15 as being like 15 times 4. So 15 makes a fourth of an hour, right? Does that make sense? So it's going to be 15 over 60, uh, 15 over 60 hours, 15 minutes, right? So 15 over 60. And then we get that that's equal to 1.25 hours, right? And so we have 10 miles. So our average speed, so it's going to be, by the way, this is just a shorthand notation of writing average speed. It's like V average, so AVG is average, right? It's just notation. You don't have to write it like that, but it's just a common notation of writing it. So it's going to be 10 miles, and then the total time that she travels for is 1.25, so 1.25 hours, and then you guys can tell me what that is. Yeah, that's it. That's correct. So the average speed that Beth travels in her commute to school and back is 8 miles per hour. Did that make sense for everybody? Yeah, that makes sense. All right, that's cool. So I hope that that's a basic example of like the distance equals rate times time thing, the formula, and then we can move on to a slightly harder problem. This is not really a distance equals rate times time problem. It's slightly harder. It's like a rate problem. Um, it's closer to what you would see in the AMC8, typically in the first 15 problems or so. And yeah, it's a bit harder. But do you guys have you guys seen these types of problems before? Or have any ideas on how we can start this? Feel free to just unmute or type something in the chat. Either way is fine. Uh, so just just give me like a way to start the problem, or like an approach of starting the problem. You don't have to type in answers or anything like that. Um, so any ideas before I start going over the solution? Ryan, I noticed you posted something in the chat. Do you have any ideas on how we could start? Okay. So the way we can start this is, or the way I'd recommend starting this is, first of all, writing down that Toby can mow one lawn in 50 minutes, right? Right? That everyone agrees with that. So Toby can mow a lawn in 50 minutes, right? So here's the next part. So in 1 minute, right? Because we'll see why we talk about only a minute. But for now, we say that in 1 minute, how much lawn is Toby gonna mow? How much of the lawn is Toby gonna mow? 1/50, right? So in 1 minute, Toby's gonna mow 1/50th of the lawn, right? And this is just Toby, right? Does it make sense? It makes sense that this is just Toby, right? Okay. And so working together, um, how so working together, can somebody tell me like the same format? So they mow the whole lawn in 30 minutes, right? Right? That makes sense. So how much of the lawn are they gonna mow? Are they gonna mow in 1 minute? Yeah. So they're gonna mow 1/30th of the lawn, right? And so we kind of see that in 1 minute, Toby mows 1/50th of the lawn, right? Right? Do we see that? Everyone sees that? And what we need for them to mow together is 1/30th of the lawn in a minute, right? Because we see that is okay. First of all, is 1/30th a bigger number or a smaller number than 1/50th? Is it a bigger quantity? We'll get to that later. Is 1/30th smaller or bigger than 1/50th? Yeah, it's larger, right? Um, so what we need, so what Toby is doing is he's mowing like 1/50th of the lawn in a minute, and what Toby and Nick need to do is mow more of the lawn, right? They need to mow 1/30th of the lawn, not just 1/50th. So in 1 minute, what they need to do is they need to mow how much more lawn? So Toby already mows 1/50th of the lawn. That's the max he can go, 1/50th of the lawn. But they need to go 1/30th of the lawn. And so in 1 minute, how much in 1 minute, how much lawn can both of them mow at the same time? So like how much more do they need to mow? And I think someone mentioned this earlier. Yeah, it's 1/30th of
Hello?
the lawn. Hello? Yeah.
I'm sorry. I don't know why you keep changing your Zoom meeting ID. And just now, when he log into another account after a couple minutes, everybody just log off and nobody let us know you changed the ID.
Yeah, that's my bad, because I thought that the Google Meet as only one. like Google Meet only lets you use a link for only one time,
Okay.
but yeah, we just noticed that it could be
Yeah, can we
repeated
please
frequently.
confirm one ID so we don't need to
Yeah,
have
yeah.
this
This is
cancel
this is the
next
only
time?
link. This is the only link that exists, and we'll let that know in future
And I
emails.
don't know how long this class been start so far.
It's yeah, approximately 20 minutes. So
Okay, yeah. So can you maybe
yeah,
repeat
yeah, yeah,
something?
yeah,
Yeah.
yeah. This
All
is
right.
this is
Thank
the
you.
only email. Yeah,
All right. Thank you.
this is the only link. All right. Sorry for the confusion, guys. So this is the only
Sorry
link.
about that.
I'll post the email moving forward. All right. So moving on. So what we were discussing, right? So then what Toby mows is 1/50th of the lawn, and they have to mow 1/30th of the lawn, right? So in a minute, um, what more lawn they need to mow is 1/30th of the lawn minus 1/50th of the lawn, right? Because that's the additional amount that they need to mow. And so can someone tell me um what this amount is? So how much more do they need to mow the lawn? Yeah, as someone mentioned, it's 2/150th of the lawn, right? Which can be simplified to 1/75 of the lawn. Yeah. So if they if Nick mows in 1 minute 1/75th of the lawn, then how much time would Nick take to mow the lawn alone? So how much time would Nick take to mow the whole lawn? Yeah. So if in 1 minute Nick mows 1/75th of the lawn, and in 75 minutes Nick mows the whole lawn. So the answer is 75 minutes. Does that make sense to everybody? How we kind of approach that problem? So yeah, this is not a conventional D equals RT kind of problem, but um, it's a useful rate problem, and it frequently shows up in the AMCs as well. And if you take math counts, that as well. Yeah. All right. So we can move on to this problem. It's kind of an extension of the last problem, but it's a bit on the it's a bit harder. So looking at this problem, does anyone have any ideas on how we could start? Yeah, the more this problem. Yeah, yeah, we are doing this problem. Yeah. Does anyone have any ideas on how we could start? Just any initial ideas before I start going over the solution. We just so initially we just want ideas, no numbers. So any ideas in the chat? Um, Hubert, Ryan, anybody, Jaden. Okay. That's a good start. So, this is also a problem that a kind of problem that shows up in the AMCs as well, or maybe just like extensions of it. But I think yeah, that's a good start. So, as someone mentioned in the chat, we'll go through the process. So, what I recommend doing in the beginning is just numbering any everything through arrows, right? So in the beginning, we can say three beavers, right? Okay, three beavers, um, four rooms in 9 hours. Does that make sense? Because it's just three beavers painting four rooms in 9 hours. So that's just how the arrows go. It doesn't have to be any particular amount. It doesn't have to be any particular order. Just make sure that um just make sure that it all works out. It doesn't have to be in any particular order. Um, so I'll just to make it to make it more to have more clarity. I'll just talk about like I'll just make the quantity that we're trying to find in the in the last row just to make it easier for us to see. So 9 hours and then four rooms. So it's kind of the last quantity out there just to make it clearer for us to see what we're doing, right? So we want how many rooms can two beavers paint in 4 hours, right? So let's say three beavers, right? I always recommend bringing everything down to one, right? So three beavers, 9 hours, four rooms, right? But keep the four rooms as it is because it's the number that we're trying to find. But I just recommend thinking about what everything will happen if the beavers and the hours or whatever the quantities are, they come down to one. So suppose that three beavers had to do in 1 hour, had to paint some rooms in 1 hour. How many rooms would they paint? If in 9 hours three beavers paint four rooms, in 1 hour, how many rooms are the three beavers gonna paint? So like again, I kind of just want to bring down everything to one so that like it's easier to see what the quantities will the well because like we want to find what two beavers paint in 4 hours, right? So it's easier if we bring everything that's not the amount that we're trying to find, which is the rooms. If we bring the three beavers down to one beaver and the 9 hours to 1 hour, then it'll just become multiple. Then it'll just become easier thinking about what two beavers can paint in 4 hours because then you just multiply or divide everything by two or four, right? Um, so as someone mentioned in the chat, yep, that's good. So in 1 hour, the three beavers are gonna paint four ninth of a room. Does that make sense? Because in 9 hours, if they paint four rooms, in 1 hour they're gonna have less time to do it, less time to paint stuff. So they're just gonna paint four ninth of a room. Just think about it logically, right? It's just common sense that if you're given more time, you're gonna do with the same amount of people, you're gonna do more if you're given less time, right? So now let's think about what one beaver will paint in 1 hour. How many rooms or how much of the room will the beaver paint in 1 hour? Or one beaver in 1 hour. Because by the way, here you assume, yeah, that's for 27th of a room. But I just want to make this clear because this problem says every beaver paints a room with the same rate. So that's why you're able to divide 4/9 by 3 because we know that every beaver paints at the same rate. If they weren't painting at the same rate, then you wouldn't have been able to do that, right? I think that kind of makes sense because like every beaver paints at the same rate. each beaver will paint 4/27th of a room. If one beaver paints slower than the other beaver, then the other beaver is gonna paint more than 4/27th of a room, and the one that's slower is gonna paint less than 4/27th of a room. Does that make sense? Yeah. All right. So now let's think about the actual problem. So the actual problem says two beavers can paint in 4 hours. So how much can two beavers paint in 1 hour? Oh, my bad. 8/27th, right? Because if you think about it, um, two beavers are gonna paint are gonna paint. All right. So as you think about it, two beavers are gonna paint in 1 hour more than what one beaver is gonna paint in 1 hour. Does that make sense? So 8/27th of a room is what is what two beavers are gonna paint in 1 hour. Because one beaver only paints one 4/27. Two beavers are gonna paint more than that, right? And so now coming to the question, how much is two beavers gonna paint in 4 hours? Yeah, yeah. I think it's fine to leave it as an improper fraction, but simplify it to um, if you want to simplify it to a mixed fraction, then yeah, that's right. It's 1/5 over 27. So because you wanna say that you have 8/27th of a room, which is done in 1 hour, but now you have more time to paint more rooms. So you just multiply that by 4 to get 32 over 27 of a room. Does that make sense? Oh yeah, I just admitted everyone. There's no one in the waiting room right now. All right. So does that make sense to everyone? How it's 32 or 27 rooms? Like just so I think the key takeaway from this problem is that um you could do it another strategy. Of course, there's like multiple strategies that you can approach the problem and do the problem, right? But my kind of approach just to be more organized, because sometimes people lose track of what they're doing and what they're multiplying and what they're dividing. So my kind of approach to solving this problem is like having arrows and like um, logical steps to every problem. So first I first I say that three beavers paint in 9 hours, four rooms. And by the way, the arrows don't have to have any particular order, but what I'd recommend, just to be more organized, is to keep the quantity that you're trying to find at the end, because then it's just easier to spot the quantity. That's all. And yeah, so yeah, three beavers paint in 9 hours, four rooms, and then we kind of thought about, oh, how much does three beavers paint in 1 hour, which is like 4/9 of a room, because obviously, if you have less time to do stuff, then you're gonna do less, right? So if you have 9 hours to paint four rooms, then you have 1 hour to paint 4/9. And then we just kind of walk through the process, and to get like one beaver paints in 1 hour, and then we just kind of looked at the problem, and then we saw kind of the constraints of like having two beavers painting in 4 hours. So from one beaver, if we had two beavers, then obviously the amount of painting they did would increase to 8/27. And then similarly, if they had 4 hours to do such stuff, then you have more hours to do more, right? So you should have 32/27 of a room. And it might sound strange that it's a 32/27 of a room, but like if you think about it, it's you're painting stuff, right? So you're actually like shading in kind of like the area, right? So you could technically have like 30 to 27ths of a room if you had like dimensions of like 6 and 9, right? Because you just you just paint like one like a whole room with these dimensions, and then 5/27ths of another room with this dimension. Does that make sense? So it'll still be a tangible amount. That makes sense, right, to everybody? All right. So this is kind of um, a challenging problem. That it's an AMC8 problem, by the way. It's a problem 16 from an AMC8. So it's a problem that builds on everything we've done so far. So I'll just give you guys like 6 to 7 minutes to just try this problem out, and then we'll talk about it at the end of talk about it to maybe in the session, or yeah. So just 6 7 minutes. See if you guys can like try this problem, and don't post answers in the chat, but just try this problem, and then we'll walk through it. All right. Okay, can you guys see my screen better? Or the problem better? All right, sounds good. So yeah, we'll just discuss in 5 minutes. We'll just discuss the solution in a minute. So let's be prepared to share if you had any initial ideas or just approaches to solving the problem. All right. Uh, we're ready to. Are we ready to share? Or you guys can either unmute or type things in the chat. Um, Chopin, not quite. Um, so I guess does anyone else have any approaches? But you're on the right track though. Ryan, Hubert, any ideas? Jaden. So it would be appreciated if you could share what you did initially to get the if you could share what you did initially to get the answers, that would be appreciated. So like, what did you do? What did you do in the beginning? Like, what was your initial first step to solving this problem? Mm-hmm. Yeah. Yeah. All right. So those are good ideas. So first of all, I so again, does anyone have any initial ideas before I share mine? Yeah. Yeah. You can go ahead and mute.
Me?
I can hear you. Yeah. Go
Oh,
ahead.
uh, average speed equals total time over total distance.
Okay.
Uh, What you need is to find what the total distance they've traveled already is, and then you have to plug in the numbers. I mean, you can plug in the numbers multiplied by 55, and you add those two together, and you do it over I believe it's 50 or something like that.
Mm-hmm. Yeah, I think that's on the right track. So just for people that don't know what's going on, I'll just break it down step by step. All right. So in the beginning, it says Kyung drives 15 minutes miles at an average speed of 30 miles per hour. Right. And then it says how many additional miles will you have to drive at 55 miles per hour to average 50 miles per hour for the entire trip. Does that make sense? What the problem says? So, um, my initial step would be since as wait, what's your name, Annalie?
No, it's Lucas. I have no idea why
Oh, my
it's.
bad. Yeah, that's fine. So, as Lucas said, that's a valid point. So we want to find the total distance and the total time, right? So we can say that the additional amount of miles that we need is x, right? So um x is the additional amount of miles that we need. So additional miles, right? So the additional distance is x. and it says that he already drives 15 miles at an average speed of 30 miles per hour. So he already drove 15 miles and he needs to go X more, right? So what's the total distance? What's the total distance?
X plus 15.
Yeah, X plus 15, right? So we already have the total distance. Now all we have to do is find the total time, right? Because we're already given that we need to average 50 miles per hour for the entire trip. So for the entire trip, we need, so V average is going to be um, V average is going to be 50 miles per hour. It's 50 miles per hour, right? So we have total distance, we have total time, or V average, and we need the total time, right? Well, what's the time that Chiang travels in the first half of the trip? So when he drives the 15 miles.
30 minutes.
Yeah, it's 30 minutes, as Lucas said. So for those of you that don't know what's going on, it's going to be a simple application of distance equals rate times time formula. So it's going to be 15 miles is the distance, and he travels an average speed of 30 miles per hour. So 15 miles, and then 30 miles per hour, and then multiplied by the time, right? So our time is going to be half an hour, or as Lucas said, 30 minutes. But we'll just keep it as hours here because we're given the rate as miles per hour. So we want to stick to hours. All right. So we've established that the first half, so let's say it's T1. T1 is half an hour. And now we have to find T2, right? So T2. Um, does anyone have any ideas on what T2 could be? Anyone have any ideas on what T2 could be? So we've already established that T1 is half an hour. So what's T2? Or what's the, by the way, T2 is the time needed to travel the later half of the trip, or like the later part of the trip.
Is it T2 equals total distance or total time minus T1?
Yeah, that's the total time minus T1, but remember here, we're trying to find total time, right? Because it's only then that we can set it equal to 50 miles per hour, because 50 miles is for the whole trip. We need the total time. We need the total distance that the car travels plus the total time that the car travels for in order to set it equal to 50 miles per hour, right? Because we um does that make sense? Because we need the total time. So T2 would be um would be the total time minus T1, but uh, what would T2 be in terms of like just our variable, just like in terms of like X and some numbers? Any ideas, anybody? Lucas, Ryan, Hubert? So what's T2 just in terms of like, I'll give you a hint, it's in terms of X and a certain constant. The T2 is like the amount of time that it takes to drive the additional miles at 55 miles per hour. Does that make sense? Why? Because like he drives 15 miles at an average speed of 30 miles per hour. So it takes 30 minutes to do that. And then we need the later time, right? Like we need the later half of the time that he needs to travel all those additional miles at 55 miles per hour. Does that make sense? So does anyone have any ideas before I review the solution? Or so T2 in terms of X and a constant. That's my hint. So I'll just due to a shortage of time, I'll just review the solution. It's gonna be x miles over 55 miles per hour. So x miles over 55 miles per hour. So you're gonna get some x some x over 55 hours, right? And then we can just set it all equal. Like we can just kind of just plug everything in the relationship and solve for x as we want to find the additional miles. So it's gonna be v average, which is 50 miles as the problem gives us, right? So it's 50 miles for the entire trip, and the total distance for the entire trip is gonna be x plus 15, as we said here, and the total time is gonna be t1 plus t2, which is one half hours plus 55 plus x over 55 hours, right? Just I'll just ignore the units for now because we know that we have to find the additional miles, which is in terms of miles, right? So because just that way it'll be easier to see the equation. So it's gonna be x plus 15 over one half plus x over 55. So can you guys solve for the value of? Can you guys tell me how to solve this equation, or have you guys solved for the value of x?
Um, I'm not sure, but do you multiply x plus 15 times the reciprocal of the denominator?
Yeah, that's
Oh,
right. So
uh,
you can multiply it by one half plus x over 55. Nice job, Lucas. So you can multiply both sides by one half plus x over 55, right? So because that's going to cancel this out, and then it's going to give us something here. So I'll just use the distributive property and I'll just distribute everything. So we have 50 times one half is going to give us 25. And then we have 50x over 55, which is like 10x over 11. And that's equal to x plus 15. So our value of x is going to be x over 11 equals 10. So our value of x is going to be 110 miles. Does that make sense to everybody how we got that? Right. So I think our call is ending in a minute. So does anyone have any questions on this problem or how we got here? So our answer.
yeah, this is sort of unrelated, but do you have a syllabus?
Yeah, we do have a syllabus. Would you like a
Yeah,
would you
could
like
you
a PDF of the
bring
syllabus?
it to me?
Yeah, I'll definitely try to send it to you this week.